Hi, my name is Cooper Robertson, and this is my analysis of the S&P Case-Shiller Index. First, we'll go over some definitions and some background on the Case-Shiller Index. So, what is it? The S&P Case-Shiller Index is a monthly index of home prices that was normalized in January 2000 to have a value of 100. The types of sales in the Case-Shiller Index are called arm's length sales transactions. These are sales that were sold at or around the market value of the home. So it can be used to get an accurate snapshot of the housing market. It does not include discounted transactions, which include a family member selling the house for considerably less to another family member, or any other outliers of the sort. Value of 100 on the Case-Shiller Index means that home prices in the specified city are the same as they were in January 2000. So a 125 means that home prices have risen 25% since January 2000. With this in mind, an index value of 100 in Seattle and 100 in Dallas does not mean that the home prices were the same in Seattle and Dallas. It means that the change in home prices for both areas is 0% from January 2000 until the specified time period. Seasonal adjustment, what does that mean? So seasonally adjusted means that they adjust the data for seasons, which are strong or weak months, to provide a better overall trend line. So if you look at the Case-Shiller Index line, there's a bunch of dips and peaks in it. So seasonally adjustment takes out those peaks and those dips. Things to watch out for with seasonally adjusted data, though. I've seen a report recently that was put out stating that people should look at unadjusted data values because the seasonally adjusted data was giving slightly skewed results. It was actually saying that seasonally adjusted data was seen to be rising, while unadjusted data was declining. So basically, seasonally adjusted data can be good for looking at the overall trend line, but when making the ultimate decision, you should look at the unadjusted values, and you should feel more confident looking at the unadjusted values. So after running the graphs for the Case-Shiller Index values over time, I've seen that all three cities have had an upward trend over time. Seattle follows the national trends more closely and is most volatile, especially when the housing market crashed in 2007. Seattle seemed to be the most affected. Boston follows the same trend but is less variable. And then Dallas is definitely the least variable. Looking at the graph for Dallas, it's hard to tell there was even a housing market crash, although the total housing prices did decrease during that time and then increase after that. It was very minimal. So the means that I calculated for each city are as shown. The mean value is the average monthly Case-Shiller value from January 2000 to September 2015. Since all these values are greater than the base value of 100, it shows that on average home prices have increased in all three cities. So underwater mortgages. Being underwater on your home mortgage means you owe more money on your home loan than the market value is on your home loan. This means that if you were to sell your house, you would actually lose money. And if you want to sell the house, you have to pay the difference out of pocket between the mortgage and what the house actually sells for. A person in Dallas is least likely to be underwater on a mortgage due to the minimal decline in prices from the market crash and the recent climb in house prices lately. So if we look at this from an investment side, someone who bought a house in Dallas in January of 2000 would have seen an increase of 55.2% growth on their money over the past 15 years. This averages to about 3.68% per year. If they were just going to leave their money in a savings account, they definitely made a wise investment, because savings account earn about less than 2% per year. But if they were going to invest in the stock market, they would not have made the smartest investment decision, due to the fact that the stock market averages 9.2% increase per year in the long run, and they only made 3.68% per year. And if they would have pulled their money out when the stock market was crashing, then they wouldn't have made the 9.2% and could have actually made the smartest investment. Standard deviations are shown. The cities have different standard deviations, obviously, because of the variation from the mean. Seattle has the highest peaks and lowest drops, which mean that the variation is very high from the mean value. This is reflected in the standard deviation, which is the highest out of all three cities. Why do we look at the range for when we look at Seattle's analysis? Seattle has a range of 92.3, and if you would have just looked at the starting and ending values, it would have been less than that. Seattle had a peak in the middle, which had a greater index value than the value in September of 2015, which means you will not get the full range if you just look at the starting and ending values. Whereas if you look at Boston and Dallas's starting and ending values, the ending value is the maximum and the starting value is the minimum, so the range is the same. So here are the correlation coefficients for each set of cities that I found. The stronger the correlation means that one city can predict the other more accurately. The closer to 1 the R value is, the better the correlation. And it shows that Seattle would be a better predictor for Boston than Dallas would be for predicting Boston's index value. So if we just look at Seattle and Dallas, are the means statistically different? So our null hypothesis states that the mean of Dallas is equal to the mean of Seattle. Alternatively, our alternate hypothesis states that the mean of Dallas does not equal the mean of Seattle. After running the regression, f statistic equals 225.99, which gives a p-value of 0 at a confidence level of 95%. With a p-value of 0, there is sufficient evidence to reject the null hypothesis that the mean of Dallas equals the mean of Seattle. I chose to take unemployment data and run a one-way ANOVA regression test to see if there's any correlation between unemployment and the housing price index. After running the regression for Seattle, I came up with a p-value of 0, showing statistical significance and meaning that we reject the null hypothesis that there is no linear correlation for the alternative hypothesis that there is some sort of relationship between unemployment and housing price index. The R-squared value is 0.1071. This means that unemployment is responsible for 10.71% of the variance in Seattle's home price fluctuation. For Boston, the p-value is 0.0018, which also shows statistical significance. The R-squared value is 0.0509, which means unemployment only accounts for 5.09% of the variation in Boston's home price fluctuation, which is about half of what accounted for Seattle's. Finally, Dallas had a p-value of 0.0065, which at a 95% confidence level is also statistically significant. which means that there's a relationship in Dallas as well. Uh, this has an even lower R squared value. It only accounts for 3.9% of the variance, which is a third of Seattle's. So overall, I found that although unemployment was statistically significant in all three cities, it did not account for much variation in home price fluctuation, with an average of only 6.57%. There are definitely better factors to look at when trying to determine what affect home prices shifting, but unemployment could be a small part in the bigger picture. Thank you so much for watching.